Hello, my name is Danielle, and I'm going to do my report on applications of marine biology on xenobiology. Xenobiology is a subcategory of astrobiology. Astrobiology refers to all of the life in the universe because, after all, we are a subcategory of life in the universe. Life on Earth could have come from a multitude of different places, including, asteroid debris bringing in life forms. It could have evolved on its own, or it could have come from splashing off of Mars. It's a really important issue for a variety of reasons that we're going to get into later. The main ones being like cultural significance, like religious, like are we alone in the universe? And the second one being like practical, like in theory, the Earth is not going to stick around forever, and are we going to be able to be alive, after the Earth is gone? And then finally, applications of xenobiology research on and how we might learn and make effects for life on our planet. This is a chart of all of the related words to astrobiology and xenobiology, which I thought was like pretty cool to see how much they're all related. The most important thing or the most common way to think about possible life is to think about replicating the Earth, because all that we know is what we have on the Earth. And the reason that marine biology is more fine-tuned for that than all of biology is because there are a lot of extrema in the oceans. But the Goldilocks zone, or the habitable zone, is where you can have liquid water. As you can see, the conservative habitable zone is a little bit smaller than the optimal habitable zone. Um, and this is exactly where there's liquid water, because we're making the assumption that since water is pretty integral to life here, then water might be integral to everywhere else as well. Although I don't think that's necessarily a fair assumption to make, but it is a starting place, I forgot the term again, even though I just had my dad look it up for me again, but basically there's a philosophy of thought that things are the way that they are because this is the way that it is possible for things to be. Now, that doesn't necessarily make a lot of sense. I mean, you have to think about that for a second for it to make sense, but here you are. So yeah, is there life in the universe? And it can be really hard for us to tell. So the actual idea itself is as old as we've been thinking, right? Because is there life beyond what we can see? Because all that we can see is what we can see. However, there's been a lot of research and development in this more recently because we're developing our technologies. And it's related to how we're affected now because, as we're going through climate change, we might be able to look to alternatives of how life might exist elsewhere and give us inspiration to how we can help life here. And, is there different chemical makeups that also are suitable for life? Or what other geological things can life live in? It might even find inspiration for how we might find life in the future. This is just kind of a cool picture of exoplanets. Oh yeah, anthropic principle. But it can be really hard for us to determine if there's life on other planets just because, even planets in our own solar system are hard for us to see, which we have found evidence of dead microorganisms on Mars, but they're not alive currently. But how are we going to know if there's life on something that's millions of miles away, or astronomical units, or light years away? And And there are actually a number of ways we can determine that, like as I talked about before, the habitable zone. Another possibility is there's actually research ongoing on NAU that I almost joined, where we were looking at like the color of the planets to see if we could detect the shade from trees. And so it's just a really great cross-disciplinary area with lots of inspirations on how we could possibly solve this problem. So this is, a scientific problem because, I mean, chemical makeups and things like that. And it is a political problem because it's like, okay, well, who's going to own or relate to life on other planets? Or if there isn't life, then, are moving life there? Like, who's going to be in control of that? And of course, it's also economic because if, we're running out of space on the Earth, then okay, now we have more space, like more places. So how is that going to work out? And of course, it's, educational. Like, how did life come to be here in the first place? And if we can figure out, how and why it is off the Earth, then that ties very well with how and why there's life here and now. If we're, well, I mean, we've been unable to solve the problem of is there life on other planets for millennia now, and we haven't exploded. So in this case, like, we're curious cats, but in theory, nothing's going to happen until something happens, like, i.e., an asteroid hits us and we haven't figured out how to, send our life onto other planets. Whoops, we're extinct now. Or the opposite of that, like, whoops, there's aliens wanting to kill us now. Whoops. So there is a little bit of practical, input to it, the survival of humanity long term. And there is a little bit of cultural impact to it. Like, of course, everyone wants to know if we're alone in the universe. It has a lot of ties into religion, and things like that. So here's, so on the top right, that was a science experiment done to like see how simplified life replicates. And on the left is a branch called synthetic life forms, which I'm almost out of time, so I might skip past that. Why should the public care? Well, I don't think this is one that we're going to have to work hard to convince, people to care about. So much in this course, especially, there's so many things that are just so connected on the earth. Like, so many people think that they aren't connected to the ocean, but then are too high of, chicken feces has caused algal blooms. Like, in the, algae blooms have come up so often in all of our school content. And so that, we just need to open up the scale a little bit more. If we're so connected to the oceans, well, then how are we connected in the bigger scope of things? Oh yeah, okay. So this is hypothetical drawings of like what alien life might look like. That's in the top right. I don't know if you can see my mouse. There's an actual picture of Europa, and then here's what it looks like under the ice. So there's the top ice crust, and then there's the ocean. And these hydrothermal vents are a lot like the vents in our oceans. And I was going to link some YouTube videos here, but I forgot. So if you're, want to contribute to, finding life on other planets, like, get involved in the research, at NAU, watch those YouTube videos. Like, literally, I just, like, looked up exobiology, and I found some of the coolest videos I've ever seen on YouTube. So I just highly recommend doing that. Other potential ways to, like, see if there's life, like, there's another theory that, like, we could detect life with our communication waves, like radio waves and light waves, but there's only going to be, a very small subsection of life that has enough advancement to communicate with waves, but like not so much that they aren't like quantumly entanglement like communication or whatever, right? Oh, that was it, I guess. Thank you.